All right, so our new unit is called Planet Earth, and our first topic is on minerals. All right, so here we're looking at, this is a granite, this is a rock. It's made up of an assortment of minerals. It's often polished and then used in buildings, used at the base of statues. It contains minerals, feldspar, quartz, mica, and hornblende. So those are some of the minerals that make up this rock. So what is a rock? Rock is made up of one or more pure, naturally occurring, non-living, crystalline materials that are called minerals. Most minerals are quite rare. There's only a few, like quartz, feldspar, mica, that are found throughout Earth's crust, which is the thin outermost layer of Earth. So a mineral, it can be an element. An element is a pure substance, or it can be a compound, meaning it's made up of two or more elements combined. So quartz, it consists of elements like silicon and oxygen. No other mineral will have these elements in the same arrangement and proportion. When we look at things like sulfur, copper, gold, and diamond, those are each made up of a single element, so a pure substance. The building blocks of rock, they're pure, naturally occurring solid materials, which are called minerals. And all rocks are made up of minerals. Some rocks, like limestone, they're formed of only one mineral. Other rocks, like granite, are made up of several different minerals, like we saw here. So just five minerals can combine in different ways to form the majority of the rocks in Earth's crust. And those minerals are calcite, quartz, feldspar, mica, and hornblende. And here we can see the images of those: calcite, feldspar, hornblende, mica, and quartz. So we can use properties to identify different minerals. So to identify rocks, you first have to be able to identify the minerals that they contain. Now, because many of the same rocks and minerals are found in different parts of the world, geologists have developed a series of classifications for describing their properties. So the properties include color, luster, streak, cleavage, fracture, and hardness. And keep in mind, properties, these are features that a material or object has. Okay, so these are the ones we're going to talk about, these important properties. So the first one we'll talk about is the hardness. So there is something called the Mohs hardness scale. It was developed by Frederick Mohs. He developed this scale of 10 minerals with a hardness value of 1 to 10. So here's that scale. This is in the textbook as well. So mineral hardness, 1 is the softest, and then 10 is the hardest. So the hardness of a mineral is measured by how easily it can be scratched. And the harder mineral will leave a scratch on the softer one. So if we look here, diamond, it is the hardest mineral. And so we use this hardness scale. So the relative hardness of a mineral, it's measured with a scale. This scale here, the Mohs hardness scale. It consists of these 10 minerals that are ranked in order of hardness. So if you have an unknown mineral, and maybe it looks like talc or corundum, and here's talc, here's corundum, you can scratch it with your fingernail. If it's talc, which is up here, it's going to scratch easily because your fingernail has a hardness value of 2.5. So if we look at the scale here, fingernail has a hardness of 2.5 on the scale. Therefore, it's harder than talc. Talc is here. So it's much harder than talc, which has a hardness value of 1. If it does not scratch easily, it cannot be talc, and therefore you can conclude that it must be corundum instead. This is just another image here showing the Mohs scale of hardness. Again, scale of 1 to 10. Talc is the softest, and then diamond is shown here as the hardest. So this is a guide to identifying minerals. Each mineral can scratch all the minerals with a lower scale ranking than its own. So for example, when we look at number 1, it's very easily scratched with a fingernail. Number 2 can be scratched with a fingernail as well. Number 3 can be scratched with a knife. Number 4 as well with a knife. Number 5, it gets harder. Now it's hard to scratch with a knife. And so on. We get to number 6. It can't be scratched with a knife, but it may barely scratch glass. So that's at number 5. Number 7 scratches glass easily. Number 8 scratches glass very easily and scratches a steel file. And then number 9 cuts glass and scratches a steel file. And then all the way to number 10 as well. Next is crystals. So this is the next property. There are over 3,000 minerals, and other properties such as crystal formation can help to identify the minerals. So crystals, they are the building blocks of minerals. They occur naturally. They have straight edges, flat sides, and regular angles. So most of the minerals in Earth's crust, they grow into these beautiful shapes according to the 6 different crystal systems. So crystals, they form when the particles in a mineral line up in a regular pattern that creates these smooth surfaces and sharp edges. So each mineral will have its own unique crystal pattern. So we have halite, wolfenite, corundum, topaz, gypsum, albite, and then here are their systems. Okay, so for example, halite, it has a cubic system. The wolfenite will have a tetragonal. This is hexagonal, and so on. So each mineral will have its own unique crystal pattern. Now, crystals that cool down slowly, they're going to form bigger crystals than those that cool down quickly. Halite, like I said, it's a common mineral. It's a table salt. It'll form cubes. Quartz, this is quartz here. It'll form the long 6-sided crystals with a pointed end. Next is color. Again, another property you can use. It's a useful starting point. Okay, it's the first property you'll notice is its color, but you can't identify based on color alone. So like here, gold is on the left, pyrite is on the right. They're both golden color, but that's not enough to tell them apart. So not all minerals are the same color all the time. That's another point to note. For example, the mineral corundum, it's made up of aluminum and oxygen. It's white when pure, but when it contains some iron and titanium, it becomes blue, then it's called a sapphire. When it contains some chromium, it's red, and then it's called a ruby. Next is luster, another property. This is the way the surface of a mineral will reflect light. So some minerals, they have a metallic luster, means they're shiny like metals, like gold or silver. So even though 2 minerals, they might have the same color, their luster could be another way to tell them apart. So other words that are used to describe a mineral's luster are words like pearly, glassy, waxy, silky, greasy, and brilliant. So those describe the way it reflects light. The next property, this is called the streak. So when a mineral is rubbed across a piece of unglazed porcelain, like this is the porcelain, it leaves a streak. And that streak is the color of the powdered form of the mineral. Okay, so the color of that streak, it gives another clue as to what the mineral's identity is. So lookalikes like gold and pyrite, they can be distinguished using a streak test. Gold will leave a gold streak. Pyrite will leave a greenish black or a brown black streak. Minerals that have a greater hardness than the porcelain tile. So if they have a hardness value of 7, they will not leave a streak. Such minerals, especially black ones, they can be crushed into powder. Graphite, that's a mineral that's used in pencils. So pencil marks that we use when we're writing with pencils, they're just graphite streaks that are soft enough to be left on a piece of paper. In this example, it's hematite, which can be a dark red, gray, or silvery in color. But then when we do the streak test, it's always a dark red-brown color. The next property we can use is cleavage and fracture. So this is the way a mineral will break apart. So if it breaks along smooth, flat surfaces or planes, then it's said to have cleavage. Mica is an example of a mineral with cleavage. We can separate layers. It's like separating the pages in a book. Not all minerals have cleavage. Minerals that break with rough or jagged edges, they have fracture. So for example, quartz, that is an example of a mineral with fracture. When you hit quartz with a hammer, it will break like glass. All right, so that's the difference between cleavage and fracture. Okay, so just looking at some different minerals and properties of different minerals. Here we have amber. The color of amber is yellow. That's a property. This is copper. The luster of native copper. It's shiny. This is jade. It will make a white streak. This is mica. It's a mineral that cleaves easily into flat sheets. Canada is the world's largest mineral exporter. It's one of the world's leading producers of gold, copper, nickel, zinc, lead, silver, iron ore, asbestos, potash, sand, gravel, and clay. There's over 500 mines and quarries that are scattered across Canada, with mining operations taking place in every province and territory. First diagram here, diamonds. These are from Canada's first diamond mine, near Lac de Grasse, Northwest Territories. And then we're seeing some coal mines. This is an open pit mine near Kamloops. Produces copper and molybdenum. I don't know if I'm saying that correctly. All right, so I'm going to pause now and we'll take a look at these couple of videos.